What are carbohydrates? Carbohydrates are biomolecules that also take the names of carbohydrates, sugar, or saccharides. These molecules are made up of three fundamental elements: carbon, hydrogen, and oxygen. They layer in a somewhat lower proportion.
Its main function in the organic of living beings is to contribute to the immediately storage and obtain of energy, especially to the brain and nervous system. This is complicated things that enzymes and smells, which at the breakdown is two molecules into glucose or sugar in the bone, which make it possible for the body to use energy to perform its function.
Types of carbohydrates. There are 4 types, depending on their chemical structure: monosaccharides, disaccharides, oligosaccharides, and polysaccharides.
Monosaccharides. They are the simple signs. They are made up of a single molecules. This made them of main source, and flu or the body make it possible for them to be used as a sources of energy and also in biosynthesis or anabolism in the set of metabolism process designed to form cellular incorporate. This is a monosaccharides look like its chemical structure. Saccharides, they are another type of carbohydrates that, as their name indicates, are made up two monosaccharides molecules. These can be hydrolyzed and give rise to free monosaccharides. Almost the most common disaccharides are sucrose, lactose, or milk sugar, and maltose, which come from hydrolysis of starch, and cebuase, and obtained for hydrolysis of cellulose. Oligosaccharides. The structure of these carbohydrates is variable and they can make up of between 3 and 9 monosaccharides molecules, linked by bonds and released when a hydrolysis process takes place. As in the case with disaccharides, in many cases, oligosaccharides can couple bond to proteins give rise to what are known as glycoproteins. Disaccharides then are changed of more than 10 monosaccharides, whose function in the body is normally related to structural or strong things. Examples of common polysaccharides are starch, amylose, glycogen, cellulose, and shitty.
What are proteins? Proteins are molecules made up of amino acids that are linked by a type of bonds known as peptide bonds. The order and arrangement of amino acids depends on the genetic code of each person. All proteins are made up of carbons, hydrogen, oxygen, and nitrogen.
And most also contain sulfur and phosphorus. Proteins make up about half the weight of the body tissues and are present in all the cells of the body, and addition to participating in practically all the biological processes that take the place.
Chemical structure of proteins. For structure, levels of proteins can be designed: primary structure, secondary structure, tertiary structure, and quaternary structure.
Primary structure. It is established by the number and order of amino acids present. Secondary structure is referred to folding that the polypeptide chain adheres due to the intramolecular force, such as hydrogen bonds, for example helix, for folder shape. Tertiary structure is referred to the three-dimensionality that the polypeptide chain adheres. The functional interaction of proteins with the body depends on this three-dimensionality. Quaternary structure is occurs with several polypeptide chains in a journal together, that is, they change at last to polypeptide chains. There are characteristics of more complex proteins.
What are amino acids? Amino acids are monomers that form the base of proteins that are vital for the proper function of our body.
Acids are composed of amino groups, NH2, which is a basic radical, and carboxyl group, COOH, which is a acid group. The proteins of living beings are composed of the combination of 20 amino acids important for the body. The union of two amino acids is due to a petit bond between the carbon of the carboxyl group of the first amino acids and the nitrogen of the amino acid group of the second amino acids. This will generate a molecule of water and from what is called a petit. Type of amino acids. There are a large number of amino acids, approximately 250 amino acids that are not part of proteins and 20 amino acids that make up proteins. Also as of amino acids, the 20 amino acids that make up proteins are classified according to the type of sign change or air group, hydrocarbons, neutral, acid or base. Second one is chemical behavior, acid, base, polar or not polar. And third one, whether or not is synthesized by the human body, essential or not essential. However, below their classification, all amino acids are important for the human body and for maintaining good health.
Essential amino acids are those that the human body is unable to generate and are obtained through foods. Of the 20 amino acids, 10 are essential ones, being them leucine, lysine, methionine, isoleucine, histidine, arginine, phenylalanine, threonine, valine, and tryptophan. Non-essential amino acids. There are 10 non-essential amino acids, and there are those that the body can synthesize. They are of great importance because they generate the proteins necessary for the proper functioning of the body. The non-essential amino acids are glycine, alanine, proline, serine, cysteine, glutamine, aspartic acid, glutamic acid, asparagine, and tyrosine. What are biomolecules? Biomolecules or biological molecules are all those molecules integrated to living beings, either as a product of their biological function or a constituent of their bodies. They come in a huge and variable variety of sizes, shapes, and functions. The main biomolecules are carbohydrates, proteins, lipids, amino acids, vitamins, and nucleoacids.
The body of living beings is made up mainly of complex combinations of 6 primordial elements: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur.
According to the chemical nature, biomolecules can be classified into inorganic biomolecules and organic biomolecules.
Organic biomolecules are all those that are not based on carbon except some such as CO2 grams and CO. These can be part of both living beings and inanimate objects, but they are still indispensable for the existence of life. These type of biomolecules do not form monomer change as in the case of organic ones. That is, they do not form polymers and can be made up of different chemical elements. Organic biomolecules are based on the chemistry of carbons. These biomolecules are the product of chemical reaction in the body or metabolism of living beings. They are mainly made up of carbon, hydrogen, and oxygen. They can also have as part of their structure metallic elements such as iron, cobalt, or nickel, in which case they would be called trace elements. Any proteins, amino acid, lipid, carbohydrate, nucleic acid, or vitamins is a good example of this type of biomolecules.
Functions of biomolecules. Healing in living beings is possible thanks to the existence of DNA. Biomolecules can have various functions such as structural functions, transporting functions, catalyzing function, energy function, generative
Importance
function.
of biomolecules. Biomolecules are essential for the birth, development, and the functioning of all cells that make up living organisms. They fulfill vital function of support regulation of process and transporting of substances in each of the cells that make up the tissues, organs, and organ system.